Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a 3D trigonometry word problem. As per the problem, an airport runway runs from north to south. There is a tall tree of unknown height beyond the southern end at an unknown distance. From the departure point of the runway, the angle of elevation of the tree is 40 degrees. From a point that is 100 meters to the west of the departure point, the base of the tree and the departure point are separated by an angle of 83 degrees. Determine the height of the tree. If a plane can climb at a rate of 75 meters per kilometer of horizontal distance flown, is it safe for the plane to attempt takeoff? Let's start by drawing a diagram for this problem. Let's assume this is the tree and this is the north-south runway. This is a north to south runway. That means the planes take off at the south end of this runway. So the departure point for this runway is its southern end. As per the problem, from the departure point of the runway, the angle of elevation of the tree is 40 degrees. That means when we look at the top of the tree from the south end of the runway, the angle of elevation is 40 degrees. This is a right angle triangle. It is a vertical triangle. We are also given that from a point that is 100 meters to the west of the departure point, so this is 100 meters, and this angle is 90 degrees because the north-south direction is perpendicular to the west direction. As per the problem, from this point, the base of the tree and the departure point are separated by an angle of 83 degrees. So this angle here is equal to 83 degrees. We have to find the height of the tree. We can label the corners of this diagram. In this diagram, triangle ABD is a right angle triangle because the tree is assumed to be perpendicular to the ground. Side AB represents the height of the tree and side DB represents the distance of the tree from the departure point of the runway. Triangle BCD is along the ground, and this triangle is also a right angle triangle because the angle between the directions north, south and west is right angle or 90 degrees. We have to find the height of the tree. Let's assume the height is h. As per this diagram, triangles ABD and BCD share side BD. So the first step is to analyze triangle BCD to find the length of side BD, because in triangle BCD we are given the measure of angle C, we are given the length of side CD. It is a right angle triangle, so we can use SOHCAHTOA to find the length of side BD. For the 83-degree angle, side BD represents the opposite side and side CD represents the adjacent side. As per SOHCAHTOA, we can use tan ratio to find the length of side BD. The formula for tan is opposite over adjacent. The length of the opposite side is unknown. The length of the adjacent side is 100. We can isolate BD on the right side by cross multiplying 100 to the left side. I get 814.43 rounded to 2 decimal places. Therefore, the length of side BD is 814.43 meters. Now we can analyze triangle ABD to find the height of the tree. This is a right angle triangle. We are given the measure of angle D. For the 40-degree angle, the height of the tree represents the opposite side, and side BD represents the adjacent side. So we can use the tan ratio to find the height of the tree. The formula for tan is opposite over adjacent. The opposite side represents the height of the tree. The length of the adjacent side is 814.43. We can isolate h on the right side by cross multiplying 814.43 to the left side. I get 683.39 rounded to 2 decimal places. So the height of the tree is 683.39 and the unit is meters. This should be the final answer for the first part. As per the second part, if a plane can climb at a rate of 75 meters per kilometer of horizontal distance flown, is it safe for the plane to attempt takeoff? In this part, we have to find whether a plane that can climb at a rate of 75 meters per kilometer of horizontal distance flown can fly over the tree or will it crash into the tree. For that, we need to analyze triangle ABD. I will draw it again. It is a right angle triangle. The height of the tree is 683.39 meters and the distance of point B from point D is 814.43 meters. We have to find whether the plane can fly over point A or the top of the tree. We can use the height of the tree and the horizontal distance of the tree from the departure point to calculate the required climb rate of the plane. We can use this triangle to calculate the climb rate a plane should have to successfully fly above the tree. The required climb rate can be calculated by dividing the height of the tree by the horizontal distance of the tree from the departure point, which is 814.43 meters. In the problem, the given unit of climb rate is meter per kilometer, so we should change the unit of the horizontal distance from meter to kilometer. For that, we should divide 814.43 by 1000. I get 0.81443 kilometers. So we should change the denominator number. (814.43 meter to 0.81443 kilometer. We can divide the numbers. I get 839.1 rounded to 1 decimal place and the unit is meter per kilometer of horizontal distance. This means that in order for the plane to successfully fly above the tree, the climb rate of the plane should be 839.1 meter per kilometer of horizontal distance flown. The given climb rate is 75 meter per kilometer. This means it is not safe for the plane to attempt takeoff because it will crash into the tree. Its climb rate is less than the required climb rate to fly above the tree. So the answer should be no, it is not safe. This should be the answer for the second part. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.